stress, strain, and Hooke's law. In this module, you will understand the concept of stress and strain and learn about Hooke's law. When a stretched spring is released, it gets back to its original shape. Similarly, when we compress a spring and then release it, the spring regains its original shape and size. Do you know why this happens? In both the cases, a characteristic property of elastic materials is acting, which is known as the restoring force. It is this force that helps the elastic materials to regain their original shape and size. When we are stretching the spring, the deforming force will act in the outward direction and the restoring force will act in an opposite direction, that is, in the inward direction. Similarly, when we compress the spring, the deforming force will act in the inward direction and the restoring force will act in the outward direction. The restoring force will always be equal in magnitude and opposite to the direction of the deforming force. The restoring force per unit area is known as stress. For example, if a force of magnitude F is applied to a body of cross-sectional area A, then the stress will be F by A. The SI unit of stress is Newton per meter square and its dimensional formula is ml raised to the power minus 1 T raised to the power minus 2. Stress can be classified into three types, that is longitudinal stress, tangential or shearing stress, hydraulic stress. Let's understand them in detail. Let us do an activity to understand the longitudinal stress. Take a cylinder made up of clay and stretch it from its two ends so that the applied forces are normal to its cross-sectional area. You will observe that the length of the cylinder has increased. In this case, the restoring force per unit area, that is stress, is called tensile stress. Now take another cylinder of clay and compress it from both the sides. In this case, the length of the cylinder has decreased and the stress in this case is called compressive stress. Tensile stress and compressive stress are known as longitudinal stress. In both the cases, the length of the object is changed and the ratio of the change in length delta L to the original length L is known as the longitudinal strain. Let us now understand what is tangential or shearing stress by performing a small activity. Once again, take the clay cylinder and apply force using your hands on both the faces of the cylinder in opposite directions. But this time, the force should be parallel to the cross-sectional area. You'll observe that there is a relative displacement between the two faces of the cylinder. The stress developed in this case is known as tangential or shearing stress. The ratio of the relative displacement delta x to the length of the cylinder is known as shearing strain. The expression for shearing strain can be written as shearing strain delta x upon L is equal to tan theta. Here, theta is the angular displacement of the cylinder from the original vertical position of the cylinder. Generally, the value of theta is very small. Therefore, tan theta is nearly equal to theta. Now, let us understand what hydraulic stress is. Take a solid sphere ball and place it in a fluid. Under high pressure of the fluid, the ball is being compressed uniformly in all directions. The force applied by the fluid acts in the perpendicular direction at each point of the surface and the ball is said to be under hydraulic compression. This compression will lead to a change in the volume of the spherical ball, but there will be no change in its geometrical shape. Internal restoring forces are developed in the spherical ball, which are equal and opposite to the force applied by the fluid. This internal restoring force per unit area is called hydraulic stress. The magnitude of this stress is equal to the magnitude of the applied force per unit area. The strain produced in this case is called volume strain, and it is expressed as the ratio of the change in volume delta V to the original volume V. Strain has no units or dimensional formula because it is the ration of the change in dimension to the original dimension. The mathematical relation for stress and strain was given by an English physicist, Robert Hooke. He performed experiments on springs and found that the elongation, change in length, produced in a body is proportional to the applied force. He presented his law in 1676, which is known as the Hooke's law. The Hooke's law states that the strain in a solid is proportional to the applied stress within the elastic limit of that solid. Thus, stress is proportional to strain, or stress is equal to K into strain, where K is proportionality constant and is known as the modulus of elasticity. The Hooke's law is found to be valid for most elastic materials, though there are some materials which do not follow this law. Let's recap. The restoring force helps the elastic materials to regain their original shape and size. The restoring force will always be equal in magnitude and opposite to the direction of the deforming force. The restoring force per unit area is known as stress. Stress can be classified into three types, that is longitudinal stress, tangential stress or shearing stress, and hydraulic stress. When normal stress changes the length of a body, then it is called longitudinal stress is equal to F upon A. When the stress is tangential to the surface due to the application of forces parallel to the cross-sectional area of the surface, then the stress is called tangential or shearing stress. When the stress changes the volume of a body, then the stress is known as hydraulic stress. According to Hooke's law, the strain in a solid is proportional to the applied stress within the elastic limit of that solid.